Hi there, my name is Alfred Bieler and I'm from Google, and I would love to talk you through something that I've just learned how to do. So I've built my first machine learning model with images, and I'll show you how to do that yourself. Like all good things, it starts with a Google search for Google Vision API, which will take me to Google Cloud Platform to the Vision AI section. And there are two components to this. On the one hand, you can do analysis of some known objects that we've pre-trained a model for you. So you don't need to do any training. And on this very web page, you can just pick a photo, drag and drop it into the web page, confirm you're not a robot. There we go. And then what will happen is the technology will go away and try and figure out what this sees. So it's identified this as a toy vehicle with 58% certainty with these labels. So it knows it's a toy, it's got Lego, wheels, aerospace, and so on. But if I wanted to build something more specific, I can go to AutoML. Let me just start a new, go to Cloud Platform and start a new model. So I'm going to walk you through the full process. On this tab, you'll see some of the photographs I've taken these of the aeroplane. What I've done is on my kitchen table, I've just put down a piece of paper and taken a lot of photos of it. In fact, 200 photos is what I've used for training. And you can see on some I put the seat the wrong way around, facing backwards, and on some I put the seat the right way around. So if I just select all of the ones that's got the wrong way around and I just download them, then Google Photos will automatically give me a zip file. Now, I don't have to use the zip file. I can combine all of those together, but I've chosen the zip file. I can just upload them, create a new data set, call it Lego planes, and I've got immediately a choice, either single label classification, which will just define whether the seat is right or wrong way around. I can do multiple label classification or identify where the objects are, but I'm going to go for the single label classification. And the next step is I can upload the images. So I'm just going to upload them from my computer. This is nice. I can point it to the zip files directly and it will just upload them, unzip them. But I could also, if I wanted to, upload JPEGs or GIFs or anything else. Now I need to tell it where to upload it to, so I can just create a bucket anywhere. And that one will do. And hit continue. Now this, I'm speeding up the video so you don't have to watch the full upload of 100 meg, but there you go, upload it, and now I can immediately upload more images. But what I've learned is if I right now first label them, then it's a little bit easier, because all the ones I've uploaded this far will be images of the seat in the right position. So select all. Actually, Another thing, the UI only shows 50 images. So if I change it to 200 and then do select all, I'll certainly select all 111 photographs of the correct seat. So let me add some labels. Some are right, and also add a label for wrong, because some of the aeroplanes that I upload a little bit later are wrong. So if I now assign the right label to all of the ones I've already uploaded, then I can go ahead and upload the rest of the wrong images before I do the training. So let me go import, and again select the file, and here's the wrong images in the zip file, and again point it at some bucket. It could be the same bucket as the previous ones or a different one, doesn't matter. And click continue. Now again, let me wind up the system to go a little bit faster, otherwise it will take 10 minutes or so to upload it. There you go, quick. So definitely the longest parts of this is uploading the images, having them processed, and doing the training on that. So those boats I've sped up a bit. Okay, now I've got my images. Let me, you'll see that there's currently 99 images that's not yet labeled. So if I click on that, I'll get all the unlabeled images, and those should be with the seat the wrong way around. There we go. Select all of them. Actually, again, yeah, show all of them. Should I select all of the 99? And if I assign the wrong label to them, done. Now I've got my training data all ready to start the training. So if I click on training, yeah, all the data is correct. Train. So a few options here. Firstly, it will show me how much data it will use for what part of the training and validation. And I really don't have enough images here to do good validation and testing. So I would have liked to have more images, but you'll see that this already works. I can choose that I want to host this model on the cloud rather than the edge. It's possible to download a model, build a model and download it. It suggests how many nodes I should use. And I'm just going to say deploy it once I'm done, and I click start training. Now it will go away and do the training. This can take 9 hours. So again, I've cut out a bit of waiting there. And I come back and go to evaluate. And you should see the model that it's got. And I can adjust things like the confidence threshold. I can see how many images it processed, the confusion matrix that will show me how many it's got right and wrong. So you can see it's unlikely to get some wrong when it actually should have been wrong. And some further data about the precision of this model, just give me an overview of this. But if I go to test and use, you'll see it provides me a REST API that I can just pass images to, or some Python code. Or in this UI, I can immediately go and upload some images. So let me just take 2 images, one right, one wrong, new ones that I've taken after the original set. So there's the wrong seat, and the right seat. And if I look at the prediction that it comes back with, there we go. It says this is a right seat, and this is a seat facing the wrong way, with 76% confidence. And voila. I mean, that was easy. It took a little bit of patience, yes, some waiting, and with the magic of AutoML Vision from Google Cloud Platform, I could take 100 images taken on my coffee table and train a model without writing a single line of code, without knowing anything about machine learning. And with that, I can enable a camera to sort of detect when there's some anomaly in my manufacturing process. Hope you enjoyed it.